Great. Well, thank you, Stephen, and thank you for the introduction, Kerry. I have tried to construct my talk to complement Stephen in many ways, because while I have a very strong interest in understanding the drivers of biodiversity and their distribution, the threats that face biodiversity in Antarctica and how we can mitigate those threats, I also have worked very closely with Stephen and others to try and make sure that the scientific research that we're doing actually has a successful transition into the policy space, in that it can change, inform and drive Antarctic policy with good conservation and management outcomes. And so I'm going to sort of try and build on Stephen's talk a little bit by providing some background before I get into the sort of nitty-gritty of the biodiversity data sets and analysis that I think can be important in informing Antarctic conservation planning. I recognise that conservation planning can cover a range of mechanisms to achieve good outcomes, but the main mechanism I'm going to focus on today is area protection, and that's largely because my research and that of my research networks has focused on area protection in Antarctica over the last few years in particular, but also because area protection is specifically mentioned under Annex V of the protocol, and I think you'll see through my talk that time and again I'll try and bring it back to the protocol, because as Stephen mentioned, the Antarctic Treaty System and the Committee for Environmental Protection works through consensus. We essentially, if we want to force change, or we want to drive change with a view of achieving good management and conservation outcomes, we need to get everybody to agree. One of the best ways, or one of the ways of increasing our chance of success in that consensus, is to make sure that we understand and are consistent with, wherever possible, the guidance that's in the environmental protocol. So the environmental protocol provides obviously a very good overall level of protection through the designation of Antarctica as a reserve, but the nature of that level of protection is not always so clear, and the protocol also provides for extra level of protection under Annex V, and there's some very clear guidance there. For example, Antarctic specially protected areas should be based on a systematic geographical environmental framework, and I'll talk more specifically about what those sorts of frameworks might look like a little bit later on, and also to protect a range of specific values. Those values are listed explicitly. As you can see there, there's a number of them. I won't bother going through every one there. But on the right-hand side, you can see how many Antarctic specially protected areas have been designated in relation to those specific values. And you can see there's a little bit of a bias there, quite a large bias, really. And I'll talk to that a little bit more a bit later on in the presentation. The location of the Antarctic, especially the current set or the current system of Antarctic specially protected areas, is shown in this figure. And as you can see, the density varies. In the Antarctic Peninsula itself and in the McMurdo Dry Valleys, there's quite a high density of protected areas, whereas in other parts of Antarctica, they are much more and much less dense. And I'll also talk about the biases inherent in this as I move through the presentation. But before I do so, I think it's important to just take a step back and think about Antarctic biodiversity. Firstly, the Antarctic, or the terrestrial Antarctic biodiversity, which I'm focusing on here, really is focused, or really is concentrated, I should say, in the permanently ice-free areas of the Antarctic continent. Now, these permanently ice-free areas make up a tiny proportion of the continent. Less than 0.5% are permanently ice-free, but they contain more than well over 99% of the biodiversity. What does that biodiversity look like? Well, for many people, including Antarctic orientated people, it's about the very obvious wildlife, the charismatic species, and penguins are a great example. Everybody, when they think of Antarctica, often think of penguins. Antarctic terrestrial biodiversity is a lot more than penguins, and if you take nothing away from this talk, then hopefully you'll remember that. There are incredible mosses and lichens, and in fact my background is of some moss that's found in East Antarctica. Very rich plant life in certain parts of Antarctica. Invertebrates like mites, tardigrades, nematodes, springtails, my personal favourite. There is a whole host of biodiversity that is not as well known, but really is, when we're talking about preserving and conserving Antarctic biodiversity, it's really some of these less known species that I'd like us to think about. And certainly that's been the focus of my and my colleagues' research over the last several years. So getting back now to the current Antarctic protected area system, there's been a range of work over the last several years that have shown and highlighted some of the deficiencies in the current area protected system. One of the first to do this really clearly was some work led by Justine Shaw, which showed how, in the context of adequacy, representation, and at risk they are, that these protected areas were not doing as well as they might. And other work since this time, since that paper, has also shown this quite clearly. In fact, just a couple of weeks ago, out of Stephen's lab, Rachel Leahy and Stephen led a Nature paper that also highlighted the deficiency of Antarctic specially protected areas in the context of wilderness values. And so this work there is now quite a substantial body of work that highlights these deficiencies. And as I mentioned a little while ago, this also relates to the taxonomic biases. And so what this figure shows is that Antarctic protected areas are much more likely to contain a vertebrate species than an invertebrate species, to the point that if you looked at the top 10 species in terms of the number of asters that they occur in, well, the least, or sort of the number 10 in the vertebrates still occurs in more protected areas than the number 1 in the invertebrates. And again, just I guess trying to highlight some of the differences and some of the biases in the current network. When we think about why we're doing what we're doing and why we're trying to drive change, I think it's also important to highlight and to understand the threats that are facing Antarctic biodiversity, or the threats that are currently present. And there's no doubt that these threats are increasing, whether that be contamination from our Antarctic stations, broader changes that are related to climate change, our footprint and how that's encroaching on wilderness areas and biodiversity more broadly. There's been a range of work, again, over the last several years that's highlighted what these threats are, and indeed, in many cases, that they're increasing with our increasing human activities in Antarctica. So I think what I've tried to do is show that there's some pretty clear motivation for increasing and for doing research that informs change around how our biodiversity is protected, or how Antarctic biodiversity is protected. And of course, the goals are not that different to goals elsewhere, where there is an incentive or a motivation to increase area protection. That is to make it systematic, to be done in a systematic way, to be comprehensive, adequate, representative, and efficient. And of course, as I mentioned earlier, if it's consistent with the protocol, then we're giving ourselves a much better chance of getting the consensus that is necessary to actually implement and to drive some of these management or conservation actions. And again, just coming back, I guess, one last time to the need to bring this close to or in line with the guidance that's inherent in the Antarctic Treaty or the Environmental Protocol. And that is to look at the right sort of spatial layers, the data, and then to use those in line with the guidance of the protocol to inform conservation planning. So now I'd like to give some examples of these systematic frameworks. And to start off with, I'll talk about some of the frameworks that have already been brought to the Antarctic Treaty System. One of the first was what's called the environmental domains. Now, these were led by Fraser Morgan and colleagues at Landcare, New Zealand, and they were endorsed by the Antarctic Treaty Consultative Parties in 2008 as one of these systematic environmental geographic frameworks. And so essentially what that means is that the Antarctic Treaty Parties have formally recognised that this spatial layer is useful to inform our thinking around area protection or the way that area protection is developed in the future. Myself and Stephen and some other colleagues published some work on the first continent-wide bioregionalisation of terrestrial Antarctica. And while other bioregionalisations had been done, this was the first to try and capture it in a slightly more holistic sense, taking into account both abiotic and biotic variables. we did an update to that in 2016, and both the 2012 work and the 2016 work were endorsed by the Antarctic Treaty Parties, again, as one of these spatial frameworks that was recognised as informing work around the development of area protection. Now, there are several other spatial, spatial layers that could also be recognised in this way. For example, some recent work that was led by Jasmine Lee looked at how these really important ice-free areas might expand under a range of climate change scenarios and the implications for the biodiversity that might be living in these areas. Again, we could sort of see how this might be a very important spatial layer as we start to think about area protection. And indeed, the work that, as I said, just came out of Stephen's lab, led by Rachel, could similarly be another important spatial framework in this respect. In terms of existing data, well, there was a process called there's a process known as the important bird areas. This was applied in an Antarctic context. SCAR was involved, as were many other countries, and actually now we have a list of Antarctic important bird areas. Again, we could see how this could contribute to our thinking around conservation planning. There's also the Antarctic terrestrial biodiversity database, the locations of which are shown on the left-hand side of this slide. Now, over the last decade, it's been one of my main objectives is to build on this work, myself and colleagues, and we've really started to get to a point now where we've got a lot of useful species occurrence data here. There's over 40,000 independent records, the equivalent, I think, of 8,000 spatial locations and over nearly 2,000 taxa. So there's a lot of information now starting to be consolidated around where species are and their distribution on a continental scale. And I think that's the important thing to remember here is we're trying to start to bring these data together on a continental scale, and that's what I'm focusing on in many of these examples. I think this biodiversity database could be and will be really important as we start to move forward with some of our SAEF work over the next several months. I think it's a great sort of foundational piece of work that we can not only use but look to build on, and I can talk a little bit more about that as I go through some of the developing work. So if we think about what's already there, we have broad scale continental layers about the environmental domains, the bioregions, some point data. I started to think a little bit more about what we actually have several years ago, and if you look at the point data, for example, it's quite patchy. There's biases where sampling and surveys are generally conducted closer to where human activity already is, and so perhaps we need to. I started to think perhaps we need to think a little bit more carefully about proxies, and so habitats are a good way to think about how we might sort of think about proxies for biodiversity data. And in this case, we use the NASA's digital elevation model and some broad scale climate prediction systems to derive a whole bunch of parameters, landscape parameters in the top and climate parameters in the bottom. We brought these together, and we're actually using some reasonably complex and sophisticated classification techniques. We defined, in this case, 8 habitats across continental Antarctica. Now, why did we focus on this? Well, I sort of gave you some general reasoning at the beginning of this slide, but importantly, these sorts of things, for example, here in Article 3 of Annex V, refer specifically to representative examples of major terrestrial ecosystems, and this habitat work could potentially, you could see how this could potentially link directly to some of the requirements in Article 3 of Annex V. In a similar way to thinking more broadly about continental scale data, I looked again, thought about the species occurrence data. We then partitioned that species occurrence data into a range of broad taxa, 34 taxa, I think. We started off using Poisson point process models, but then we moved into a related set of models, which were based on a Gibbs process called area interaction models. I did this work in collaboration with some colleagues at Landcare New Zealand, Fraser Morgan and Tommy Robertson. Fraser generously provided literally weeks of high performance computing time to run some species distribution models. And we actually have now essentially what are habitat suitability models for each of these 30-odd taxa. We're still in the process of understanding the best way to utilise these data, but in terms of the protocol and the guidance in the protocol, it links very closely with the requirements to identify areas with important or unusual assemblages of species. And again, you can see here trying to do high quality, cutting edge research around some of these species distributions, but with a view of linking it back directly to the Antarctic Treaty and the protocol in particular. So I talk about bringing this together, and I think this is really where we should start to think about some of our cross-theme linkages in SAEF. I think, you know, if we start to think about bringing together these layers into a more systematic and holistic way, and then we start to drill down through them, we can identify areas that warrant protection. How we do that, though, is still very much a work in progress, and I think focusing on this area within SAEF and across themes could be a very productive area of research, because if we do that well, if we can clearly justify a more holistic set of areas that we think warrant protection, and we can convince other parties, and we can bring this as a multi-authored proposal to the treaty or the Committee for Environmental Protection, then I think we've got a very good chance, of at least moving along this road to progressing and developing area protection. There are challenges, of course. How do we validate the data? How do we select the areas and prioritise them? What about values that we aren't considering, proxies and data deficiencies? Future-proofing for climate change. And of course, one that often comes up, particularly in relation to the marine environment, is evidence-based versus precautionary approaches. In terms of challenges though, and I've alluded to this a couple of times, I think the most important thing to get across the line is consensus in the Committee for Environmental Protection, because with that consensus comes change. And with that change comes improved environmental management, conservation outcomes, however we want to describe it. All of it relies on the committee all agreeing to undertake a certain management or conservation action. We have made some progress. I was very pleased to be involved in the organisation and convening of a joint SCAR CEP workshop last year on developing the systematic area protection of Antarctica. We held this in Prague in July, like I said, of last year, and this was just prior to the Antarctic Treaty Consultative Meeting. We had over 50 people attend from 20 countries, and both from policy and science backgrounds. Importantly, we also included some people that weren't just from Antarctica, and some of you might be familiar with the work of Mandy Lombard. And Mandy did a great job of introducing, to many people at least, the concept of systematic conservation planning and showing how applicable this sort of process could be to Antarctica, and trying to convince some of the parties that were more apprehensive, I suppose, that it wasn't actually that scary, and that there was a clear path to applying these sorts of processes in Antarctica. This workshop generated a lot of discussion, both at the workshop itself and then at the CEP meeting afterwards. Following some fairly complex and protracted negotiations, the CEP did actually endorse further research to investigate the application of systematic conservation planning in Antarctica. And this, in my mind, was a real success. And again, this to me leads on to some of the work that we should be thinking about. And indeed, we've already put into the proposal for SAEF, and especially with some cross-theme linkages to contribute to this. And that's to thinking about how we inform this conservation planning across both the terrestrial and coastal biomes, how we integrate various inputs into biodiversity forecasting, and how we understand and improve the path to impact, particularly through some of the work that's planned under theme 3. So I think given the time, I'll leave it there, but I'm very happy to answer any questions if we have any time. Thank you.